Okay, rectangles. Students will be able to recognize and apply the properties of rectangles, not of, sorry. There's a few typos in this one that I noticed after the fact, guys, so I'm sorry about that. Apply the properties of rectangles to determine whether a parallelogram is a rectangle or not. So, if a parallelogram is a rectangle, remember rectangles, all rectangles are parallelograms, but if we stumble across a parallelogram that is in fact a rectangle, then we know the diagonals are congruent. Now this is the main difference between a parallelogram and a rectangle. Like, this is what makes it rectangle specific, is that these diagonals here, not only do they still bisect each other, because remember a rectangle is a parallelogram, but now these diagonals are actually congruent with each other. So AC is congruent to BD. Now this is the main requirement that is specific to rectangles. And there's one more too, and we'll talk about that. Those will be numbers 4 and 5. But let's talk about numbers 1, 2, and 3. And these three are requirements, but they are already requirements for parallelograms. And since they're already a requirement for parallelograms, we can leave them as requirements for the parallelograms. And just know that, hey, if it's since a rectangle belongs to the parallelogram family, these three requirements can just stay in the parallelogram category. They still apply to the rectangle, but they don't necessarily they don't necessarily apply only to the rectangle. They also apply to all parallelograms. So let's just write those three down. They're nothing new. They're ones that you've heard before. The first one is that opposite sides are congruent and parallel. Okay, opposite sides are congruent and parallel. Remember, that's true with any parallelogram. We've learned that already. What's another one? Well, how about opposite angles are congruent? That's another one that we already learned about parallelograms. Well, it's true in rectangles as well. And consecutive angles are supplementary, meaning consecutive meaning angles right next to each other. And we've talked about that as a property of a parallelogram, and it's also a property of rectangles. And this is more supposed to be requirements, so we might want to make a little asterisk and say this is more of a property, because just because we have consecutive angles being supplementary does not necessarily mean that it's a rectangle. So we should say over here that this is a property, not a requirement. And that's my bad for putting it in there. Okay. The last two, these are ones that apply only to rectangles, okay? So these are rectangle specific. And so the fourth one is the theorem that we learned up here. Oops. Sorry about that, I meant to use my highlighter. Yeah, it's the theorem that we learned up here. Let me rewrite rectangle specific here. I'm just going to write rectangles for now. The program does some weird things sometimes when I try to undo. Okay, so we learned up there that if a parallelogram is a rectangle, then the diagonals are congruent. Not only do they bisect each other, but they are congruent. So we were going to say that. We're going to say diagonals are congruent and they bisect each other. Alright, that is an actual requirement for it to be a rectangle, is that the diagonals need to be congruent and bisect each other. And as long as the diagonals are congruent, they will bisect each other, so that's kind of nice in this situation. Okay, The next one is that all four angles are right angles. And this is kind of one that you've already known, right? That all four angles are right angles. And you've known that, right? That a rectangle has four right angles. And so, there you go. And that's why, with these two requirements, that's why we've said before that a square is actually a rectangle, because it meets these two requirements. So a rectangle meets all of these requirements, but these are the only two that are rectangle specific, right? Remember, these three apply to all parallelograms, and these two apply to just rectangles. So very important for us to understand that. So there's really only two requirements that we're going to add to our sheet, to our triangle tree, or our quadrilateral tree, not triangle tree. So these two are really important for us to add those to that tree diagram that we have. Let's do some practice problems. Okay, so this one says quadrilateral MNOP is a rectangle. Now, there's no drawing here, so I think the first thing I should do is just make a little drawing. It doesn't have to be much. MNOP. Okay, and it says if MO, well, what's MO? Well, let's look. Remember, the reason why I did this drawing is we wanted to see, hey, MO is a diagonal. Ah, okay. And PN is 9x plus 5. Oh, well, look, PN is a diagonal as well. And it says MNOP is a rectangle. That means that MO has to be equal to PN. Remember, because our rectangles have to be congruent. Well, MO is 6x plus 14, and PN is 9x plus 5, and you can see where I'm going with this. We have a way to solve for x. So we do a little algebra, subtract 6x, subtract 6x, subtract 5. We get that 9 equals 3x, and therefore x equals 3. Okay, there we go. Yeah, you're going to see a lot of problems like that where all you're doing is setting your diagonals equal to each other and solving. Because if it's a rectangle, they are equal to each other. So here's one just like it. This is quadrilateral ABCD is a rectangle. If AC equals 7x minus 8 and BD equals 5x plus 2, find x. So go ahead and find x on your own. And I would pause the video, and I'll put the answers up there in just a second. Okay, so once again, when I sketched this out, I saw that I had diagonals that were congruent. And so I set those two things equal, and just did some algebra and solved that x equals 5. Alright, that should be good for this page. I'm going to go on to the next page on the next video.